Hello everyone, I am Jayani Hewavitharana from the Ballerina AI team, and today we are going to discuss about how we can unleash the power of AI using Ballerina. In today's talk, we will first take a quick look at the evolution of AI and its shift towards integration, and then we will see how we can use Ballerina for AI use cases with an overview of the connectors and libraries that we have. Then I will do a demonstration on implementing an AI use case using Ballerina. And finally, I will conclude by introducing some future developments that we have planned to further expand the AI capabilities of Ballerina. So let's get started with the evolution of AI. So the history of AI can be traced back to at least the 1950s. And traditional AI and machine learning primarily falls into the category of artificial narrow intelligence or ANI. In this type of AI, we have specific models that are capable of performing specific tasks, and these are trained using task specific data. And these models can perform exceptionally well for these tasks and can often surpass human capabilities as well, but they are only able to do this specific task that it is trained to do. And we also have different types of models to select from depending on the use case that we're implementing. And when we are doing AI use cases using narrow AI, there's more focus on the model implementation part, including data collection and preparation, constructing model architectures, training and tuning models, and also deploying models so that we can use them. But we are now slowly moving away from this paradigm of narrow AI and moving into general AI or artificial general intelligence, where we wouldn't have these specific models for specific tasks anymore. We would rather have a general model which can adapt to various different tasks and perform them exceptionally well. And considering where we are at now with AI, there are several terms that gets used quite often, like generative AI, foundation models, and of course LLMs or large language models. So generative AI is basically the creation of synthetic content like text or images using different AI technologies. This is not a new concept, it has been around for quite some time, but the popularity of this has increased with the introduction of GANs. But even then, the usage of these generative AI technologies has been condensed within the AI community itself because using this required the understanding of how this model actually work. But the accessibility of generative AI has increased with the introduction of foundation models. So foundation models are large models that are pre-trained using very large amounts of data. And these are general models that can be adapted to specialized tasks with minimal customizations. So this significantly reduces the efforts needed to train customized models for various different tasks. It also improves the accessibility of AI technologies because even these models does not require a deep understanding about the AI methods that are used to actually use these models. And finally, when talking about large language models, these are a type of generative foundation models that specialize in generating natural language. So I think this is by far the most popular type of foundation models that is in use now, and we can see it continuously being adapted to various different tasks like chatbots, conversational agents, and many more AI use cases that gets released these days. So, what is new and what is different now compared to how AI used to be before? So, now we have this very vast collection of pre-trained large foundation models that we can easily adapt to different use cases. And most of these models also have user-friendly interfaces to access them. So with this, even people who have no idea how these models actually work can access them and interact with them using these interfaces like ChatGPT, Bard, DALI, Midjourney, and many more. And from a developer perspective, these large models are hosted by companies like OpenAI, Microsoft, and Google, and they are exposed through APIs. So we can easily connect to these models using these APIs and easily integrate them to different AI use cases as well. So with these advances, implementing AI applications and use cases is now relatively simplified, going from an era that is focused on extensive model training to an era of model integration. So now let's take a look at how, with this background, how we can use Ballerina for AI use cases. So as I previously also mentioned, AI is now becoming more about integrating with models that are externally hosted and less about training specific models from scratch. So this is now becoming a integration use case. And Ballerina is the language for integration, which makes it ideal to implement modern AI applications. And in addition to that, Ballerina also now has a collection of connectors to connect to various different foundation models. So these models include chat models, text models, models for embeddings, and also models related to images as well as audio. Additionally, we also have connectors to fine-tune large language models for various different downstream tasks using custom datasets. And we also have the support for doing vector mathematics with the maths.vector module that we have in Ballerina now. And we also can easily connect to vector databases like Pinecone and VBA using the connectors that we have for those as well. So in addition to this, we are going to continuously expand this collection of connectors that we have for AI, so we can keep on improving the AI capabilities that Ballerina has. Let's now take a look at how we can use these connectors to implement an AI use case. So for this, what we are going to do is domain-specific question answering. So to give a bit more context, what they're doing is answer questions regarding a particular domain using OpenAI's GPT-3 model. But there's a small limitation in doing these sort of domain-specific tasks using these foundation models. That is, the knowledge about this domain can be limited or outdated because the model is only trained using the public data, and the models are not trained using the most up-to-date or most recent data. So to avoid this limitation, we can provide information from the related document as context to the model. So the model can learn from the information that we provide in the prompt and refer to that to answer our question. So this is called the model's ability to do context learning. And for this, we need to find the relevant information for the questions using whatever the documents that we have. To do this, we can do a similarity search. Uh, so how this is going to work is we can extract content that is similar to the question by comparing the embedding of the question with the embeddings of the content that we have, and extract the content that has the most similar embeddings. And finally, we also need storage for the documents and also the embeddings. So for this, we can use local memory or traditional databases. So with this, we can load all the embeddings for the content that we have and explicitly do a similarity search to find the most similar documents. So for this, the math.vector module that we have introduced for Ballerina will be useful. So the other option would be to use vector databases. So using vector databases, we can store the documents and the embeddings in the database. And when we want to retrieve the similar documents, we can send the embedding of the question to the database, and it will internally do the similarity search and fetch the relevant documents for us. So for this demo, we will use vector databases for storage. So this use case actually has two parts. The first part is populating the vector database, which is the initialization part. So for this, we will implement a Ballerina program, which feeds some data from a Google Sheet and then we will obtain the embeddings for the content using the embedding model. Then we will send the documents and the content embeddings to a Pinecone vector database where we will store this. And the second part is the question answering service itself. So for this, we are going to implement a Ballerina service, which takes a question as a request. And then we will send this question to the embedding model to get the embedding for the question. And we can send this question embedding to the Pinecone vector database, which we populate with data during the initialization phase. And it will internally do the similarity search and fetch the similar documents for us. Then we can construct a prompt uh, to add the content from the similar document as the context for the model. Then we can send the question and this constructed context to the OpenAI GPT-3 model, which will refer to this context and provide an answer, which we can then send back as the response for the question. So now let's take a look at how we can implement this use case. So first I will show the data that we are going to use. So we will be reading the data from this Google Sheet. So the sheet has a subset of data that we have taken from the documentation of Choreo, which is WSO2 SaaS development platform, which helps developers to build, deploy, observe, and also manage cloud native applications. So this Google Sheet has two columns. The first column is the title of the document and second column has the content of the document. So now let's go to the code and see how we can implement this use case. So the first thing we will do is the initialization part, or the part where we read the documents and insert it to the vector database. So for this, we are going to write a Ballerina program. So I have already set up some configurable variables that we are going to need. So we will need an access token for the Google Sheets and the ID of the sheet that contains our data and the worksheet name. And we also need the OpenAI token to access the OpenAI models. And for Pinecone, we have to create an account and get the API key. And also we have to create an index to store the data and get the service URL for that index. And we also have a couple of constants defined as well. The namespace refers to the namespace within the Pinecone index where we are going to store the data. And we also have the name of the embedding model that we are going to use. So before we insert the data to the Pinecone vector database, we have to get the embeddings for the content. So we will start off by implementing this get embedding function to get the embedding vector of a given text. So we can do this using the embeddings connector that we have from in Ballerina. So the first thing we have to do is import this connector. Then we can initialize a client to use this connector. Authorization, we can provide the OpenAI token. Then we can use this client to implement this get embedding function to retrieve the embedding for this text. So for this, as the input, we will provide the text and also we have to give the model name that we're going to use. Then from this response, we can extract the embedding vector and return it from this function. So now we can use this function to get the embedding for any text. And now we can implement the logic to read the data from the Google Sheet and insert them to the Pinecone database. So for those, we will import the uh, connectors for Sheets and Pinecone as well. Let's import it as Pinecone. And we will initialize the clients for these two connectors as well. For this, we have to provide the access token and we'll insert the client for Pinecone as. For this, we will give the Pinecone API key and also the service URL of our Pinecone index. So now we have the clients, we can implement the logic to read the data and insert to the database. So first we will initialize an empty array of Pinecone vectors to store the data. Then we will read the data from the Google Sheet. For this, we will provide the sheet ID, sheet name, and the range which one we want to read, which is the columns A and B. Then we can iterate through each row and extract the data in each row. First, we will get the title, which is in the first column. Then we will get the content, which is in the second column. Then we will get the embedding for the content. Then we can add everything to the array of vectors. So this vector record needs to have an ID. For that, we will provide the title of the document, and as values, we will provide the embedding. And we will also add some metadata to add the content. So now we can add this array of vectors to the Pinecone database. So for this, we will provide the namespace of our index and also the array of vectors. So this will insert the data to the Pinecone vector database. We actually won't need this variable over there. And now we can run this code to insert the data to the database. So this will read the data from the Google Sheet and then get the embeddings for the content that we have in the content column and push everything to the array of vectors. And then it will finally insert this array of vectors that we have constructed to the Pinecone database. So now it has successfully inserted the data to the DB. Now we can go ahead and implement the service as well. So for the service, I have already imported the connectors that we are going to use. And I have also set up the configurable variables. And I have also initialized the clients, the OpenAI text client, which exposes the GPT-3 model and the embeddings and also the Pinecone client. And here also we have a set of constants defined. The maximum number of documents is the documents that we are going to fetch from the Pinecone database. And then the maximum number of words would be the limit of words that we are going to have in the context so that we won't run the risk of going over the token limit. And then we have the namespace of the Pinecone index and the names of the embedding and OpenAI completions model that we are going to use. We also have the get embeddings function, which we also use for the initialization, and this count words function, which we will use to count the number of words that we have in the prompt. So the first thing that we are going to do is construct a prompt for a given question by obtaining the relevant documents from the Pinecone database and constructing a context using the content in those documents. So we will maintain the context in this variable and we will also keep track of the context length. So the first thing we will do is get the embedding vector for the question. Then we can send this question embedding to the Pinecone database, which will do the similarity search internally and send us the relevant documents. So for this also we will provide the namespace and the vector, which is the embedding vector, and also the top k, which is the number of documents that we are going to fetch. And we will also include the metadata in the response because we inserted the document contents as metadata. Now from this response, we can extract the data. So this can be nil as well. So let's add a check and return an error if we don't have any data. Then we can iterate through the documents that we have fetched and add the content from these documents to the to the context. So first we will get the content from the uh, document which we add in the metadata. Then we can calculate the context length if we add this content to the context, and if the length surpasses the maximum number of words that we want, we will break out of the loop, and if not, we will add this content to the context. So this constructs the context to answer the question, and then we have this instruction which tells the model to use this context when answering the question. Then finally, we combine this instruction, this context, and the question together to construct the full prompt. Now we can implement this service. So we have initialized this service with one get resource function to get the answer for a given question. So for the first thing we will do here is get the prompt using the construct prompt method, which we just completed implementing. Then we can send this constructed prompt to the OpenAI completion model or the GPT-3 model, which will use the context and provide us an answer. We can then get the answer from the response and return it as the response for this request. So we can run this service as well and send it a request to see how it also works. Okay, service is now running, so we can send it a request. We will ask the question how to deploy service. So this will answer it in the context of Choreo because the documents that we have are related to Choreo. So it constructs the context based on the document and it provides us with this answer. So this is one use case that we can do using the AI connectors that we have in Ballerina, and we can do many more use cases like this. So let's get back to the slides. Okay, so before concluding, I will introduce some future developments that we have planned to further improve the AI capabilities of Ballerina. So, as I previously also mentioned, we will keep on adding more connectors to the collection that we already have so that we can keep on expanding the capabilities that Ballerina has for AI. And then we have the AI agent framework coming, and this is a Ballerina module which supports implementing software-based agents that use large language models. So with this module, we can implement use cases like AutoGPT. So we can provide these agents with tools that can perform various different actions or tasks. And the agent will be designed to do the reasoning to identify the correct combinations of tools in the correct order to carry out specific tasks that are given to it. And in summary, so Ballerina is a very rich integration-based language that is ideal for integration use cases. And AI is now also becoming more of an integration use case. So by providing the support for AI for Ballerina, we hope to bring the immense integration capabilities that Ballerina has for AI use cases so that the developers can get the best of both worlds. So with that, I will conclude today's talk. So if you want to find out more, you can head over to the Ballerina for AI page and also check out our Ballerina AI samples in the Git repo. And please do join the Ballerina AI community as well. The links will be shared in the chat. So thank you very much for joining. So if you have any questions, uh, feel free to ask them. I will try my best to answer.
Hi, Jenny. Thanks a lot for that great session. I can't see any questions that have come through the chat box yet, but we can give people a bit more time if they want to ask any questions. And also, everyone, you can feel free to unmute yourself and yeah, ask any questions you want. Does Ballerina math.vector module have the parallel capabilities as NumPy?
Currently, no, it does the vector calculations sequentially as in a for loop. We have the capabilities to do the similarity and the distance measures. So the moment this is not done parallel like 9.5 would do, but we can certainly bring those capabilities to Ballerina as well to the vector calculations.
If there are any more questions, you can always raise them on our Discord server. So yeah. All right. Over to you, Chani.
Okay, yes, so thank you. very much for joining the talk today. And as Ashwini mentioned, if you have any further question, you can go to our Discord channel and raise them over there as well. And thank you again and have a good day, everyone.